This is the average of those.
Sorry guys, I'm a little bit late today, so I apologize. There was no connection.
And the average speed of the passenger train
As I tried to set
is
up
different. That's just a
the
way.
college
Just the
internet,
way.
so it would
This is
take me a while to
yeah, I just
get it
wanted to
done.
clarify that.
Okay,
Like
so
that is like you say
all right,
the
so
average
let
speed
me
of the freight
just
train, but
sort
technically
of
we know that the freight train isn't really going at the same exact
looking
speed
at
at all.
the
Even
assignments,
because like it takes a second for it to accelerate, right?
and
And it takes some time to for it to decelerate.
we
So
also
we'll have
have
different speeds in that period of time. But
independent
overall, that is
project
the
being
average speed.
posted
That
um,
is different from this. We don't care. This is not what we're being
for
asked,
that, so independent project.
See,
right? So
how I think maybe in the exam, in some question will ask me.
well,
Just making
usually
sure.
if a question asks you this, this will usually be the average speed of something.
Every speed of the speed,
Post it.
speed, and
Yes. So if you if it's the
So
difference between the average
by space, so make sure they're gonna double check
and the average speed of one object. Okay.
the topic. So we're gonna have something like it's under the independent it's under the the assignment, so we can always download and try to work through it.
That was from 175, right? On movies. It was so much better.
So, you're also going to get two for 120 or only for 125?
I think only for 125, because I think they do it based on.
Okay, so show the instructions how you get it done. But usually this one gonna be due at the end of semester. You have to use a survey, the data set that we have, the new data set point. This is basically for the final project.
Third for one.
By the way,
So the data set, the data is for the final project only. Okay, just making sure. And it's due on December 17th. This is independent project. It is for those who want to get an A or A plus. Okay. So if you just aim for an A minus, you don't necessarily have to do that. Um, so this is for A or A plus. Okay. Plus and 2% of the extra credits.
I think that there is a way that formula didn't work for whatever reason with an integral of.
So that 2% is basically added to the final grade. So that's a lot. For example, if you miss like 10 points on the exams, so that's going to be 1% of your grade. Okay. So I just want to tell you that this is a huge difference for those who want to complete them. Okay. So that's the thing. Um,
On the space of function.
I see.
so we're going to start with chapter with objective 6. I actually post some chapter under the content,
One, two.
and I post everything for that. This is objective 6.
For the wrong thing.
Objective 6. So we have to focus on uh chapter 6, 7,
Well, it feels like I feel like
and
engineers.
6, 7, 8, I believe is one of the things.
So, since I was in a kernel vector space, instead of thinking of the operator that
Yeah, so all the chapter was posted. Also the last objective was kind of complicated, so it's a different file. It's a long, very long chapter. It basically contains many different parts of the objective about statistics, how we're gonna deal with the a quantitative data set, the chi-square test, is all of that. The one tail, two tail is all of this. I just want to let you guys know in advance because I know I have checked the grade, and then some people actually complete objective uh, 5 and 6 and something like that, which is great. All right, so now we're going to um we're going to look at
Um,
like the new questions for objective 6
radical
and
functions.
okay.
Yeah, just introducing.
You are correct. This unit is harder than nothing.
Gonna be.
And
so I just want to come back to chapter 7.
It's harder.
And
Exams 3 and
the
4.
topic about.
Well, what we've covered so far from after exam 2,
Mm-hmm.
and it's going to be, I guess, radical. Like it's going to be like radicals and give me 1 second. I can check. What is after
It's
that?
just that it's like it's like all the part of rational functions, long division, radical functions, and then
So what we have so far is like gonna have like so to estimate the common level.
We're gonna do more problems for radicals.
yeah.
We're gonna use like we use the mean, the sample mean as essential.
Yeah, you have to stop saying that.
As essential.
You
Okay.
said that to me too about that.
So back to objective 5.
Yeah.
If we have enough data sets, so let's say the n was greater than 35, something like that. The sample mean will be automatically normal. And that's very important perspective that we should know. Okay, so we're gonna use the sample mean as essential, and then to estimate the population average. Okay, so I just want to put it down real quick. If we have like a full control on the population parameter,
Just because of one, because it's already in Q.
Right.
which is the population mean and population standard deviation, we should have full control on the sample that we pick. Okay.
6 or 12.
But they're relative.
However, when it go to objective 6, we have
And
full
that's-
control
that's from
on
Q
on a sample, right? How much
And then
do we understand
it should be degree 12.
Well, that is.
the
no,
population
that is
parameters?
that would be for cubic root of 2, comma, fourth root of 3.
Okay. So this is a thing that we're going to estimate the mean based on
That we should have. There was
the z-score back in like a long time ago. So we're gonna have the z equal to x bar minus the mean,
Couple of guys got it.
and we divide it by the standard deviation. Let me just pull it up real quick.
Yeah, it's definitely, she definitely.
Minus the
I like
mean
it. It's really fun. It's more.
and
I think
divided
that
by the standard
If I
deviation.
didn't have the background that I have in algebra, I would be struggling a lot more.
Yeah, I don't know. I like algebra. It used to be my favorite area in math before.
You covered everything coming up for it.
Over radical
And
n.
you've landed on harmonic.
I've never done geometry.
You've never, I guess so, yeah. I need you to do geometry because you need help on that.
Oh, you're
So based on that, we can estimate the population mean is basically this guy.
Oh, you should read. Have you read Tu's book on like manifold?
So that's gonna give us we can solve this one algebraically. So we can take the x bar
I guess Atia McDonald, which is
Oh,
really
like
nice.
plus and minus.
It's commutative.
Yeah.
It's fun. I mean, it's fun. Just yeah.
I don't know. Maybe algebra. I am the. And Francesco.
Lazio is
Z times the standard deviations over radical n times the standard deviation
You're right.
I got right, but
Oh.
over radical n in this case.
this is very fun.
So the ones that they.
All right. So this estimation
Always starts with one kind of.
estimation is only good
This is a topic.
if like we have a big n and or we know the population's standard deviations, which is a little O right here we call sigma. The population's parameters, population standard deviation. Population standard deviation. But realistically speaking, usually if you try to estimate the population average, meaning that you cannot obtain the population standard deviation over here, because we don't have enough like the data set points to get I mean we don't have we don't know exactly like how many data within the population, so there's no way that we can compute a population standard deviation in some case. Well, some people might use like historical population standard deviations, but that might not be good for the estimate. So like back in so then if
That's credit.
we use a small sample size, if we only have
Take the exam and it lets you skip
a small
class.
sample size n,
So I was like, should I? Because I need to get into like a better math
Yeah.
next year. I'm not waiting till like next year to get into a biology class.
Right, okay.
So I'm like,
So-
Available.
I think that,
oh, I'm so sorry. I do apologize. I need to let someone inside in the classroom.
you definitely.
Yeah, somehow with teaching, I did not notice that. I do apologize. So which is why I always have to wait until people got into the class before I start teaching.
Like,
I'm so sorry about that. And if we only have like a small sample size,
Yeah.
and or
Like, so you wanna take the.
we do
exam-
not know, we only have
mid
a sample standard deviation. This is what we usually have.
because it takes like 10 weeks to get the results back.
Then
in classes.
we have to conduct like a new analysis we call the t-test. Okay, we need a
I
new
mean,
test,
would it be a problem with your major if you started taking biology classes next year?
new pattern, a new distribution we call the t distribution.
Well,
Yeah.
would it?
Okay.
Your major would be a problem with
For
you.
me,
So
It would be a problem for you.
so back in like
these courses out the way, and if I start biology like next year, I still need to take. I'm trying not to
so
overload.
back in like 1907 or something like that. So it's like a student t-test distribution.
Crazy. So if I like, I'm trying to get them out like.
So we're gonna have
Can you, so what is the math?
so
for
that one is
biology?
something that
I need.
we have it.
Yes,
For chem and for biology.
chem and bio. So.
It was developed by the guy
Biology, yeah. I that one I
Um,
still have to wait.
a long
but
time ago.
Take
It's
pre-calc before taking chem and then.
back in 1907 or something like that. It's been more than 100 years ago.
Alright.
And then we developed like the student t-test. He from England,
Wait, so-
and then so he got that distributions being developed is gonna change along the way. So they have different functions. We have a PDF different function for that.
Levels course, but I don't want to do it.
Mhm.
History. So it has like a pretty long history for that, but this is very important. It was developed by
There's
Um,
probably the best way to see is to try, like, I don't know what your semester looks like right now.
I'm trying to get to the
You definitely.
yeah,
supposed to start
to the
studying.
history. So back in like 1908, and so this guy actually developed a t-test.
There's going
And then
to
it says
be-
that, well, when you have like a small sample size, and especially we do not know the population standard deviation, then the z-test is no longer valid. It's no longer accurate for the estimation. So which means that using a t
They don't do, well, I don't, actually, they don't, that's even an option, they just don't do.
Not
using a t distribution
I guess,
Uh,
I didn't even.
will
know
give
When the concept of a winter term is foreign to me.
will give like a better estimate.
You don't teach calc.
So I will definitely gonna show you how to get it done. And so instead of we replacing the z-score and by the new score we put t-score. So the plus and minus meaning that we're gonna have like, so we have a plus and minus z-score, so which is where plus and minus is gonna be on two-tail estimations. And you're gonna have to replace, hey, so now the t is no longer the z is no longer valid because it's not gonna capture the range that we have. And then he have to replace by by the t-test with the sample standard deviation S. Okay. So this is a very important thing for the entire objective 6 because like I said, it's basically
Talk about it. I'll send you. You can
one of
send
the
me
very
the,
important thing when you try to estimate the population parameter with only a very small sample size and or we only know the sample standard deviation. So as a matter of fact, when you have something like 16th and it is normal, right? So when it is normal, we don't really care. It has to be the least test, okay? And then because it's also give us like a known population standard deviation. When the sample size was 90 and it is not normal, it still have to use the z-test because the sample size n was big enough. It basically does not make any difference between the z and the t-score. And then when the sample size has 11 members and it is from a normal population and it doesn't have the population standard deviation, so we have an unknown population standard deviation, then we have to use samples, and meaning that we have to use the t-score. Okay.
But my friend last year, she got a B in the chemistry, so she cannot end.
And then the estimate always be the sample means that we computed from a very small sample, so that would be 488.
That work. You need to get like the update.
3.7.
B is not incorrect. Yeah, it should be used for Z and T. It usually doesn't matter anyway. So
It's pretty high.
yeah, Z and T it doesn't matter. For both of them, yeah, honestly. So because it's got to be pretty much the same thing, the same score for that. So it's just a little thing.
They went and had
When we have like a big sample size, it doesn't matter which one I'm going to use. It's end up with the same thing, right?
Yes.
All right, so let me just try another questions and see. The estimate always be the average is 502, and then the size was 12,
Yeah,
and
that's
then
not- that's not-
it is
it's
from
not-
a population with a distribution about which we know very little. So we have to be easy with the t-score, right? At size 14, it is normal with unknown population. This one we unclear. This one we can't use anything. It has to be coming from the normal curve. And the sum was yeah, it can be used either T and Z, it doesn't matter at all.
You gotta be on this specific
B
exam.
was
You need to
incorrect.
Your grade.
The sample size was 14. It is with the unknown, yeah. It's let me just double check. Oh, what C was all right, so this one was like Z, we have 100, and then we also have a known population standard deviation. Yeah, that when we have like a this part when you have like a population standard deviation, and we just analyze that a little
No, no,
bit.
no. You should go to them.
When you have like a known population standard deviation, it usually doesn't matter, but for some reason I like just well when you have like the known population standard deviation, then we have to go with the z-score. Okay, so that's one of the thing.
You need to.
But when you have like the sample size equal to 110, usually it doesn't matter which one, honestly. So I just want to summarize that because this question most likely going to be on the exam. You have a sample size big,
and give you an A.
and then you can use either T and Z. Honestly, it basically have no problem with that.
What kind of sociopath would go to teach a college class and want their students to take
The Z or T.
the whole
Okay.
thing?
When you have a small sample,
maybe he will give
but it have to be normal curve, and
Oh, well, just go. talk to
And
your
it
professor.
is-
Like,
has
there's
a,
no- what I'm trying to say is there's
like,
you're definitely
the-
you
a
should
known
not be guessing.
population standard deviations.
It's not set in stone.
So meaning that we have to use
Like, for-
the t-score. Okay,
It starts. with
and
understanding what
whenever you have something like big sample,
See you later in class.
and then we have a population standard, big or a small sample, big or small sample. And then we also know the population standard deviation, which is this one. And then we can
That's given.
use the z-score.
Don't technically end, I mean, my finals technically don't end till like December 22nd.
Yeah.
All right,
So, like,
and
I don't wanna,
when you have
know,
like
be
small
studying for
datas
throughout the year and then forgetting, and then study for finals.
and not
then
normal,
go
for
back to it.
example,
So,
not normal.
you won't forget it, because also.
So literally
most of the stuff
is
that
we can like neither of them, right? So neither z or t. So we have to be the normally distributive in order to be used for the estimation. So that's one of the thing
I would
we should know.
now they don't have.
Okay, so
But.
yeah, it's a little thing that we should
I
pay
can
attention to that.
give
It's
you all,
literally
like,
not going to be like a big deal.
an open
Um, so let me
Okay.
just go back
covered,
to-
start with that. A lot of, or a good amount of topics.
the
already
Alex.
we've done them in an easier
yeah,
level. in
This one is not going to be on the exam, but you still have to master it. Because it's you have to generate like a bunch of sample and then
Make sure.
you're gonna do all of this. Yeah,
So
you know,
I think that is really important.
I have a little,
for the, cementing what you learn.
I have a little eye problem over here, so we need to make sure that it's gonna generate 20 of them, and then your job is to figure out, hey, for what's confident interval will be contained within the average or out of the average. So 75% confident level for part 8. So let me just analyze what it is. So we're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So they have a problem counting as well. So we got 14 of them that technically within the range, right? So the mean was computed within the range of this confidence level, which is good. Only 4 of them. So we can see that one of them, 2, 3, I can 4, 5. Yeah. Hold on.
It can vary slightly.
I have a problem counting. So 1, 2, 3, 4,
I think that's
5. So meaning that's 16, right? So let me count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Hold on. Yeah, I really have trouble counting it. So we just simply count, like the range that is inside of, between the means.
because I think we're
And
already
let me count them again. 1, 2, 3,
like polynomial functions and like graphs.
4,
So that
5.
comes
Hold
in
on.
handy. Like,
1, 2, 3, 4, 5, 6, 7. Yeah, 7 of them. Meaning that there 13 of them was within the bow. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, so okay, so the probability will be like 13 out of 20, which is 0.65.
it's very hard to.
Okay, so 13 out of 20 with 0.65 is contained the population mean equal to 60. And the same thing for that, when you build up with the bigger confidence level, and which is 95% is going to give you the bigger range. Basically give us less information, but it basically gives you a better containment of the population standard deviation, so we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So meaning that we're gonna have 1, 2. Yeah, I have trouble counting this, so let me.
Nice, I mean,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm so sorry. So meaning that there will be 2 of them was basically out of the bounds. Basically the mean is not contained within that estimation. So that'd be 2 out of 20. It's so it's basically 90%. It's 0.9.
Slightly depend
Double
on.
check that. Yeah, I'm all yeah. Is that 13, 18? Yeah, it's just how many of them? Yeah, so 13 just count a number of the range that would within the comp level. Yeah, so if I would have trouble counting it. And
Also, like, on Academy.
So-
It's great.
usually when we count the comp level, it's you basically get more content, more interval that contain the population mean the course because the range is gonna get longer, wider. So meaning that is basically have a better chance to contend the average equal to 60. And we should expect to find more 95% confident level that contain a population more than 75% confident level that contain a population mean. The bigger
That's because so.
the higher the confidence level, the wider the interval. So basically is we gonna have a better chance to contend
Like Calc 1 is your first
the population average in this case. So
introduction
nothing
to
really special,
math.
but we can try another one. But like I said, I'm really bad at doing counting because I'm not having a good eyes. So we can always check what this kind of question like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So 15 of them, for example. And then for 90% confidence, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I think there was 19 of them. I'm not quite sure yet because I have to check. Yeah, so that's good. And then we just simply answer the questions like usually the 75% confidence level will be included in the 19 percent of confidence level for that reason. It's always be like that because it's 70% basically have a narrowed range of the interval. For the 90% it basically have that wider range. So we have to be contained inside of it
Yeah.
and so on and so forth. Okay. So
Was
so
awesome.
that's one of the
Yeah.
things we have for the question.
Yes.
I don't believe that.
Yeah,
I
okay. So now we're gonna move up
wonder-
to the next part. This is more likely on the exams. So I need to cover a little bit more.
Well, but that's because math, unfortunately, if it's taught wrong, like if someone fails in their pursuit of teaching you math early on enough, then you kind of grow up always thinking that it's just not for you, which is not the case, because math is for everyone as long as they understand it in a way that makes sense.
Okay, so
Like my math journey is horrible. Like I had
the question gonna give us like the x bar equal to 62.7.
grade, I had geometry and she like dropped out mid-year. So we didn't have half of the mid geometry course. I didn't take any math in 10th grade.
And then we
11th
also
grade, I
have the population standard deviation was 16, so we can just put it there right here.
like stop caring.
Why did you replace in math 101? Did you take the place?
And then we also have
I was 6 points off.
the n we go to 80 sample.
Oh, then, yeah, then you.
And then we need to compute like
submitted
75% confidence level,
to like
90% confidence level.
me up and I never got back.
Hmm.
I was just 6 points behind.
I think, yeah, then you can definitely cover it, and don't put too much pressure.
The z-score that we have will be like 1.96 for critical values.
If there's going to be a tougher semesters.
Or
then
96 for
make
critical
sure
value.
That you are taking classes that you are.
Okay,
confident, like, you are
so
confident in the
uh,
background enough to take.
and then this is for 95% confidence level. You can check it quickly on a calculator, show you what it is quickly. And for z-score
If you have to be busy,
equal
at
to
least be busy and
1.15
note that
or
in terms of just like understanding it, you can make it. That being said, I think that
75%
there's
confidence level.
because you're also, like,
So the
building
confidence level is
all
simply
there's nothing. I think only good can come from
the
like,
likelihood
trying to like kind of go a little faster.
that, you know,
And it's
I have like
the mean is content
fellowship.
on an interval.
Horrible.
that's all. These are all.
So let's say
it's you know.
would take 75% chance. So when you do the sampling like 75 times out of 100, so it will be basically contain the population average. 75 out of 100. That is what it means.
That's
What if
the,
I ride a bike?
that's great. That's another thing you've got going for you.
Okay, so we're gonna estimate that for 75%. So let me just double check.
I don't know. Going to go to the other ones. Fireline.
Well, let me tell you a story. I was supposed to jump from a.
So we're gonna take like 62.7
Yeah,
plus and minus.
don't pray anything, and then they just kicked me.
I don't think we have to do this, but generally, I hope that the calculator gonna help us
The hardest part.
much better. Times the standard deviation, which is 16
So yeah, I think that you can. I sent that
over
video,
to
Yeah.
radical n.
like check it out. Like a lot of that stuff is actually.
You know what's funny? I teach kids how to swim, but I don't know how to swim.
What do you mean? How does that sounds. That does not sound like a.
So
Wait, what actually? What
I'm
do you-
being so serious.
No, describe.
so
what
we
you
just do the
mean.
calculator for that. So I let me take 62.7
If you for some reason found to go
plus and minus 1.15 times the standard deviation 16 over radical 18, I'm sorry.
So
So we should get something like 58.36.
did not know that.
And so how many decimal point we have to do? With one decimal play will be 58.4, and that one should be 67.0. Okay. So that still be contained on the true average equal to 60. So 60 is to be between 58.4 and 67. So this one's 60. Okay. And we do the same thing for the 95%. And we just simply change that to 1.96.
The textbook has like makes no
Just
sense.
do
Go on.
The textbook makes like no sense.
Yeah, sometimes that's why I think it's helpful to like use all the resources that the internet offers, because sometimes like just the fact that it's sometimes they have a weird way of kind of communicating something which is actually not helpful at all.
So the answer that I have is
Thankfully, there is enough
this one.
resources out there now that you can definitely help for it.
And it's not that bad, but like sometimes I don't know what they're talking about.
Okay, so the same thing that we so if you
Yeah.
if you see this question on the exam, just simply undo it, and then we change back to 1.96. Then you should get something like this. Okay.
So, yeah, check out the textbook. There's also, I sent a link for another, like, I put the link in Lumen as well for another textbook. Again, use all the resources that this.
You don't necessarily have to compute it twice, like for that reason, just change certain functions on a calculator, and then you can just figure out the results.
And variation. Variation is really not that.
Yeah,
complicated.
it's-
Um,
So now we're gonna enter the values. Over here was 55.3, and then the mean was 60.
it's very useful.
Yeah. So our estimation should be contained as, yeah, for 95%, 100%. 0.1. So let me double check the answers. Hold on. 70.1. Hold on, what's happening? There's something wrong with the math over here.
Are we gonna go over, you know, when they have like the square root and then they have like a number outside of the square root
Where's that number?
on like sitting down
Yeah,
like
it's-
here?
Yeah,
Yeah,
Like right
I don't
here.
understand this. It's like,
On that,
what's wrong?
yeah,
Let's double
so
check that.
when it's not a square root.
like, what do you
Yes,
mean, like
that's what it
this?
It's different.
Okay,
So if
Well,
the,
I
if the
don't
square,
know.
so if the square root is.
Is that 60? Did I
If
do?
you're
Hold on a
already
second. Let me
thinking
just
of
double check that real quick.
Or the
The
square root
mean
of
was like
100,
62.7, which is plus and minus
then what you are looking for is a
1.15
number
times the standard
which
deviation
elevated
over
to the power of
radical
2,
18. So that's what it is.
the root of 2.
We
It
have
gives you- right?
yeah.
Wait, if I give you the square root of 4,
Mhm.
the solution is 2. Why is it 2? Because 2 to the power of 2 is equal to 4. The nth root applies that same
62.
property, but to a power bigger than 2. So the
It's
biggest
60.
root, for example, is the number that elevated to the power of 3 gives you what you have in the radicand, which is the argument of your root. Or general, once you generalize it, the
Yeah,
nth
let me just double
root
check. It's
of a number x is the number y.
that should be very
elevated to the
straightforward.
x.
Oh, you probably use n equal to 80. I don't know why I put n equal to 18 for some reason. So I'm sorry. Yeah, n equal to 80. So I put n equal to 18, which is, I'm so sorry. My eye doesn't feel good today, so I do apologize for that.
Yeah.
It's the n equal to 80 instead of 18. Yeah. I'm so sorry. Yeah, so so then we're gonna change that to like over 80. You should be able to get it quickly. Yeah, we should get like 60.64 and then 64.8. Yeah, that's what it is. Yeah, I'm so sorry about that. It just my eyes doesn't look good today, so I think I have to go to see my eyes doctor very soon. Yeah, which is why it's different from the result that we have.
If you want A to go over
And
up,
just hit equal, I'm gonna get something like
multiply by
60.64. I'm so sorry.
because if you multiply by A.
Because there's no way you can get it wrong. It was a very simple math that we have to do.
The other side.
And all of a sudden that, I got the result was kind of like much different from the answer. So now we change it back to 1.96. And then we should be able to see the calculation. Yeah, I apologize for that. So I can, yeah. And then we changed back to 59.2 and 66.2. Yeah. So that makes sense. And then we're gonna play the same game again with a generator sample, and then you're gonna tell, uh, you know, 75% confident level, right? And then 95% confident level. So the 75% should be close. The percentage of sample content to the population should be close to 95%, but it might not be exactly 95% because this is the likelihood. And then from the 95% confident level, we kind of say that there is a 95% probability that the population is between 55 and 62%. And then the 75% confident level is narrower than 95% confident level, of course. The greater the level of confidence, the wider the confidence level. So this is the thing that we should have those notes. All right. so let me just go to the next part. We still have a lot of questions. Seriously. We still have a lot of them.
Are you the one making our final? I hope that's where like everyone failed their final.
Is there like is it an infamous?
Yeah,
No.
like I always hear that like, the math courses here are like really hard because the final just doesn't match what you learned. Yeah.
It's often the case because you often finals tend to, they tend to.
So the question basically gives like
But
the sample standard deviation, which is S.
you'll get enough practice to know where you're going.
So then we have to use the T, right? And the margin of, so let me just point it out real quick for that. So this is what we call the margin of error. So this is basically like how much difference between the population mean and the sample means when we estimate the population parameters. So this is what we call E. It's nothing really special, just take X bar plus or minus something. So that's the difference between the population and the sample. So let me just do the math for this. We're gonna enter the value like 45. The point estimate was 5.64, and the population standard deviation was 2.73. And the critical values, the question says 95% is 1.96. This always be the fixed value for the for the Z-score. And yeah, but the question does not ask us to use the sample standard deviation. The questions simply provided with the population standard deviation. So this one is given as well, since the population standard deviation was given. So we don't necessarily have to use the T.
Jasmina said her Zoom got disconnected. Can you let her in?
Oh. Oh, I see. I see. Yeah. It's given. So we can use the Z instead. I'm sorry. And we just pick one. But this question was sort of asking us to use the population standard deviation, but that one was given. The sample, usually it's just how we generate it. So in other words, that we're going to take that. And then we just compute it. All right, I got you, Hashan. Yeah. And then we're just computing that. I think the calculator going to help us. We compute it already. And are we happy to just simply plug that in? You take 5.64 minus 0.8. So we're going to get this part equal to 4.84. And then you're going to take 5.64 plus 0.8. You're going to get 6.44. Okay. So that's 95%. As simple as that. It's very straightforward. Yeah. So the question just simply compute it for us, so you don't necessarily have to do it. Just write up the answers quickly. Yeah. The point estimate is this is what we call the points average. The point estimate always be the sample mean, because the way that we compute the averages between the sample and population is exactly the same thing. But if you want to prove it, it's because of Fisher statistics. It requires us to have like a certain understanding what it is. And then so we're going to accept that a point estimate is the sample average. So we're gonna use it as a point estimate. Okay. The margin of error, I just want to make sure that the margin of error is simply that we add or subtract is the difference between the population means minus the sample mean. Okay. So that's the thing that we should notice. Goodness.
Yeah. I feel like it would be hard to kind of.
Yeah. All right.
Intermediate issue.
So,
Great.
all right. So the same thing for that. I think we did that before. This one's very straightforward because I don't think you're gonna get that question on the exam, honestly. Yeah. So this one is definitely gonna be on a test. Very important because it basically we don't have a calculator to help you. You have to compute everything on a calculator. So this one is generated from the system. It's relatively straightforward. That one is requires us to understand like which one that we have to do. The question gives uh
We need some.
the population standard deviation. So this is where we have the known standard deviations, right? The standard deviation, which is called a sample standard deviation. Sorry, population standard deviation. This is basically the same thing, just making sure. Okay, and that's gonna be equal to 10.
Maybe first meeting first, and then online. Let me go through it.
And then what we have so far, yeah, I have some iPhone. Just making sure that if it gets some number wrong, just please remind me. The psychologist select 150 children, so n equal to 150. And then the mean score was this is coming from the sample. We're gonna get the X bar equal to 106. And then it also gives like 90% confidence level. So 95% confidence level doesn't give you that. We can always go back to the chart. Actually going to post you the chart later on. Or we can just get it from the calculators. So 90% we could z of 0.9. But you have to divide it by 2, but this is all for the left tail. The confidence level is on working for both sides. So when you read 90% confidence level, it should be something like that.
Yeah, in one class, the lead.
So this is 90% confidence level,
This one in the.
90%.
Questo correggendo devo finire oggi a
Meaning that each tail going to be 5%. So this one going to be 5%. And this one going to be 5%.
Adesso oggi ho fatto le.
Ci ho chiesto. Se io potevo.
Right. So when you read out the z-score, when you compute it, so you have to go from like the z of 0.95 or z of 0.95 instead of looking at the 90% confidence level. So that's kind of weird. So all we have to do is just simply take, if it's 90%, we're going to take 1 minus 0.9, and then we divide it by 2, we got 0.05. So if you go with 0.05, you're gonna get the same thing, which is 1.645 or something like that. So this is what we're trying to do. Okay. All right.
A is equal to. So what is the thing that is?
Nice 1.645 something. I don't think I have enough space for that, but anyway, so
The first thing. You go and go.
let me just erase this.
Isolate. First step is to isolate the whole parenthesis, right? How do you do that? How do you make it so that the only thing on this is whatever inside that parenthesis?
0.05 equal to 1.645, something like that. Okay.
No, yes.
All right. So when we compute it, let me just copy the performance over here. When we compute it, we just simply plugged in.
No, rewrite everything, but you can get rid of the parenthesis. That's only all you found. Now what you are left with, the next step.
The
Isolate.
so the z have to be like go to 0.05.
To get it, we just isolate that. Right? Yes, exactly. So what you.
When the confidence level was 90%. Okay. All we have to take like 1 minus 0.9 over 2, something like that. Like 1 minus 0.9 over 2. If you don't want to use the chart, so we can always do that. The confidence level is basically work for 2 tau, like 1 and 2 tau. So it basically estimate the upper and then the lower level. This one is 0.05. All right, so we can plug that in. You can take like 106.
How do you get rid of this? Yes.
Plus and minus the z of 0.05
So that would be, what are you left with?
times, I'm sorry,
Now,
times the standard deviation was given by 10
so you can isolate A. You just have to-
over
Yeah.
the square root of one is that 150, yes. So that gonna give us the final answers. Most likely, like for objective sake, is this one calculation. So we should get something like 104.65. You should 104.7 and then 107.34, something like that.
I'm reading.
If you spend like more than 2 different calculations, it's not correct. It should be one calculation you should solve for the confidence level on a calculator. So,
Deal with.
any question?
Deal with, they promise you, I deal with it like.
All right.
Just.
Let me do one more before we go, because actually it's just very long. I don't think we have enough time to fit it to
No,
finish all of that.
You did not.
Okay, I don't, like I.
I think it calls for that as well.
Don't know.
Yeah, you can play around with that. T of negative 1.5, can just use the calculator. T of
Science says.
negative 1.5 with degree of freedom equal to 8 degree of freedom.
Blankly, and then I failed my music test. Mind you, she only gave us like 3 days to review the content, so I couldn't start, but like I did flashcards and I still like all the sounds sounded the same.
8 degree of
Because it was
freedom.
a music test, you have to listen.
They want to shade the areas,
She played
right?
the audio.
And then the answer for that was 0.91, something like that. So we can solve it. 0.914.
My Greek and Latin.
Probability.
No, the Greek and Latin roots of English. It's the worst class I've ever taken. No, it's beautiful.
Right, yeah, I see what you mean.
It's
The
so
it's etymology.
hard.
Yeah, it's hard.
It's hard.
It's really hard.
And
I'm
like,
surprised they do this, but
no.
that's hard. I mean, I used to, yeah,
So let me just undo that again, just making sure we see that. And we find the probability.
I mean, if you had, I promise you, if you, well, that partly is because Latin is closer to Italian, so it's easier to me.
Duh.
But Greek is an
Which
exceptional,
are,
all ancient languages.
0.914,
Greek is an
something like that.
exceptionally complex language.
Yeah, it should be very straightforward. You can try another one.
So it's.
And then
it's-
it just simply use a calculator of t of
It's an exceptionally
probability of
complicated
negative
language with
0.75,
exceptionally complicated constructs, like the way
and
people
then
express
4 degree of
is very,
freedom.
very convoluted.
No.
So we're gonna get 0.7525, something like that. Yeah, it's not a problem that much. So
Same time, so I'm not fluent in both. Like I speak both, but I'm not very fluent in both. No, I like struggle with both. Like sometimes I find myself switching over to Spanish or like Spanish to English. So I never properly learned both. So now I'm like learning this and I feel like I'm learning English and that it's like the worst class I've ever taken.
You're also, so one thing that I hope you do realize, this is your first episode.
No, and I'm
Hey, so
I'm already feeling it's, you're
I
still.
think that's pretty much what we have. I'm so sorry for like a certain current incident that we have in this morning.
Really just in the loop. Like.
Then the same thing for that, we just low for t of 0.8. I'm not gonna go over that. But we have to put down 9 degree of freedom is given from the questions. 9 degree of freedom. So we're going to put that. We should get
And you don't have. So.
negative
if
0.883,
your concept- the one thing that I would
something
say,
like that.
if you
Negative
are not
0.883. Okay.
That does not mean you're
Yeah,
failing.
we can try another one. It's just basically a matter of using a calculators, but the t degree of freedom is just using I'm sorry, the t test is based on the degree of freedom and the confidence level as well. So you have to be extremely careful. This is what we're trying to find the value that represent 90% area, so that'd be 0.9. And it also give us 4 degree of freedom, and then that's going to give us negative 1.55, no 1.533. Okay, that's not a problem. So this is complete different from what we have earlier. So let me just pull it out right here. And
It's. You're always taking part.
so for the previous one, we just simply look for the probability, but now I want you to look for the score. Okay,
Yeah, so I don't have.
I want to find the score.
No English, no sign. Oh,
That gives
I mean, I come from a.
90% areas confidence level
Those four courses.
probability with 4 degree of freedom. So the degree of freedom usually I denote by df on the calculator, which is why you're gonna see like df most of the times.
I live by the philosophy that.
The degree of freedom is n-1.
But the harder thing. And.
We're gonna cover that next Tuesday.
Enjoy.
Just making sure we have this done.
no, that's actually like kind of crazy.
Well, it's not the difficulty, the complexity and the beauty in.
So we're gonna wrap this up like
There's a lot
next
to-
Tuesday. I know it's been a little bit late, but you know, this is the best I can do.
It's like saying-
And before the third exam, we're definitely gonna give you like some exam review questions, like just go through some problems, but I don't think we're gonna have a full review compared to the second exams. So I hope that you're gonna do these questions.
You're not.
All right.
Oh, not bad.
I think that's pretty much what we have today. Any question, any concern?
You're not. Certainly.
All right. So let me take attendance real quick. I don't think I see names over here. Jasminer is here. Malika. Yeah, I would definitely do that. Do we have school on election day? Yes, we do have school, unfortunately. Malika is here. Yes. Annie. Rachel, and
You're not feeling this.
Selena is not here.
No.
Sharon, she got some connections problem, so
If I promise you that the worst thing is
Samina.
yourself, you're a busy college student. The second one classes is when you're sick.
yeah, I mark her present. I mark her present. Sarah,
Instead of taking.
I think most of you here, so I just mark all of you present with 27 people. Yeah. I'm very sorry about the incident that I have like in the early lecture, something I cannot count, and also I put it in the wrong value. Make sure you're gonna remind me again. Sometimes it's you know. But anyway, so that's pretty much it. I hope you guys gonna have a wonderful weekend and see you back next Tuesday. Take care.
To go. So, yes, exactly.
Oh yeah, so here next Tuesday. So hold on. Sarah,
No, we're called, no.
make sure that I'm gonna get your names.
We're off our, for this class, I would dare say that we're probably.
It's right here.
easily
I'm sorry about that.
the
All right.
harder thing that you're.
So take care.
But like, the thing about the tree.